Hello students, today we'll discuss IB Physics HL Paper 2, May 2017, times on 1. My name is Melim. I am located in Baku. Here you can see my mobile and email. To prepare for exam you can use IGMH, huge textbook from Oxford 14 or short textbook from Tim Kirk, Oxford 14. From examiner, I recommend you to have IB Physics Guide, which has syllabus and also physics data booklet with formulas, and this booklet will be available at the exams. This exam is 9 questions for 2 hours 15 minutes with calculator. Let's look to cover page. So calculator is required. Clean copy of the physics data booklet is required. Let's start. Question 1. The diagram below shows part of downhill ski course which start at point A, 50 meters above level ground. Point B is 20 meters above level ground. A skier of mass 65 kilograms starts from rest at point A, and during the ski course some of the gravitational potential energy transferred to kinetic energy. From A to B, 24% of gravitational potential energy transfers to kinetic energy, so that the velocity at B is 12. So, from A to B, decrease of potential energy only partly turns into kinetic energy. Let's find how much is the decrease of potential energy. mg delta h, change of height, we get some amount. 24% of this amount will give us so many joules. That turns into kinetic energy. Formula for kinetic energy: half mv squared equals the energy. Rearranging this formula for v squared and then taking square root, we get 12. So this question done. Sum of gravitational potential energy transferred into internal energy of skis, slightly increasing their temperature. Distinguish between internal energy and temperature. Internal energy is the total energy, kinetic and potential of molecules in an object. Temperature is a measure of the average kinetic energy of molecules. The dot on the following diagram represents the skiers as she passes point B. Draw and label vertical forces acting on the skier. So because we have centripetal motion, resultant force should be down. So mg acts, it is weight, acts downward and is greater than reaction force. So I labeled reaction force and weight. One arrow, another arrow. The heel at point B has a circular shape with radius 20 meters. Determine whether the skier will lose contact with the ground at the point. So we have reaction force and weight, and resultant force make object to move in a circle. So centripetal force is mv squared over r. We can calculate it. mg is so much. Resultant force is actually centripetal force. It is mg minus reaction. So reaction will be 169, not 0. So more than 0. Hence contact is not lost. So skier is pressing on the road. The skier reaches point C with a speed 8.2. She stops after a distance 24 meters at a point D. Determines the coefficient of dynamic friction between the base of the skis and the saw. Assumes that the frictional force is constant and the air resistance can be neglected. So energy change equal work done. All energy is kinetic energy, and work done is force times distance. So we can find force. Force appears to be with 3 significant figures, 9 to 1. Then we use formula for dynamic friction, and coefficient of friction is force over reaction. Reaction is mg. So we find the answer with 2 significant figures because mass is with 2 significant figures, so minimum. At the side of the course, flexible safety nets are used. Another ski of mass 76 kg falls normally into the safety net with speed 9.6 meters. Calculate the impulse required for the net to stop the ski and set an appropriate unit for your answer. Impulse equals force times time, or it equals at the same time to the change of momentum. In the end, momentum is 0. At the beginning it is mass time velocity, so we get 760 newtons per second without paying attention to the sign. Explain with reference to change in momentum why a flexible safety net is less likely to harm the skier than a rigid barrier. So from formula for impulse and change in momentum, our formula for force equals change in momentum divided by time. In case of a rigid barrier, delta T will be small and force big, so harmful. Question to outline what is meant by the principle of superposition of weight. So 2 points. When two waves meet, the resultant displacement is the vector sum of their individual displacement. So 2 points. One, you talk about the story, and second, what happens in the story. So here we have red laser light, information about separation, distance, and distance between maximums S 4.7. So we put all this information into the formula for fringe separation. We arrange this formula for lambda, and we get with two significant figures answer in meters. Explain the change to appearance of the interference pattern where the red light is replaced by one that emits green light. So according to the formula, green light has smaller lambda, so S will be smaller, fringes closer to each other. Once of the slit is now covered, describe the appearance of the pattern on the screen. So we have bright, actually we have diffraction on one slit. Bright central maximum, subsidiary maximum on either side. The width of the central fringe is twice than the width of the subsidiary fringes. Intensity of the pattern is decreased. So only 2 points are required. So one of these 3 points. 2 of these 3 points. Two renewable energy resources are solar and wind. Describe the difference between photovoltaic cells and solar heating panels. Solar heating panels convert solar energy into thermal energy, and photovoltaic converts solar energy directly into electrical. A solar farm is made of voltaic cells of area. Average solar intensity falling on the farm is, and the average power output of the farm is. So calculate the efficiency of photovoltaic cells. So intensity equals power of the area. Power equals intensity by area. So total power is falling is 6. Efficiency will be useful by total multiplied by 127%. C. Alternative generation method is the use of wind turbines. The following data are available: length of turbine, density, average wind speed. Determine the minimum number of turbines needed to generate the same power as the solar cell. So power equals 1.6 megawatt. One turbine formula power is this, where A is area swept by the blade, so we use PR squared, and then divide total by each to get number of turbines. We get 6.5, so we should make integer number, whole number of turbines, 7. Explain 2 reasons why the number of turbines required is likely to be greater than your answer to C. Efficiency is less than 100, and not all kinetic energy is transferred to kinetic energy of the blades. Thermal energy is lost due to friction in turbines or generator. A heater in an electric heater passes power when connected to 240 volt electric supply. It is connected to the electric supply by copper wire. The following data are available. Calculate the current in the copper wire. So a bit confusing. Why? Because it talks about copper wire, but because formula is power equals current time voltage, and very small voltage falls on the copper wire, we use only heater. So current will be power produced in the heater by voltage, approximately 35 amperes. Calculate the resistance of the cable. So from formula we have this equation for resistivity. We arrange it for resistance and we get this value. Calculate the power dissipated in the cable. Now cable. So formula for power, substitute values for current. Current will be the same because in series connection. Resistance we have just calculated and we get the answer. Question 4 continued. Explain in terms of electron what happens to the resistance of the cable as the temperature of the cable increases. So as temperature increases collisions of electrons with vibrating atoms, drift velocity decreases and current decreases. As voltage is constant but current decreases, resistance increases. The heater changes temperature of water by 35 degrees Kelvin. The specific heat capacity of water determines the rate at which water flows through the shower. State an appropriate unit for your answer. So power multiplied by time will give us the energy, and this energy goes to heat the water. We can divide by delta T 2 parts, so this part and that part. Then we'll get the following. So power will be C delta T m over delta T. So mass per second, so it is flow rate. Mass per second will be power divided by C delta T, and we get the answer mass, so joule per second, so kilogram per second, actually kilogram per second. State the quark structure of meson and baryon. So just memorize meson, quark and antiquark pair, and baryon consists of 3 quarks. A possible decay of lambda is shown by Feynman diagram. So here this is the time, and this will be the position. Okay. Explain which interaction is responsible for this decay. Strangeness, so let's see. So strangeness before was 1 and then is 0. So strangeness change. So strangeness is not conserved in the decay because the strangeness quark changes to up quark. Strangeness is not conserved during the weak interaction. So 2 points. So first you explain why strangeness, you think that strangeness doesn't change, and then you relate it to weak interaction. Draw arrow heads on the lines representing anti-U anti-quark and down quark in the so the time is going that way, so antiparticle will be against the time and particle will be along the time. Identify the exchange particle in this decay. So it is weak interaction, so exchange particle is W boson. So if we concentrate on this junction, we have strange quark with charge minus half turns into positive plus 2/3. It means that W is negative 1. So it is W minus boson. Outline one benefit of international cooperation is the construction of the use of high energy particles. It lowers the cost of individual nations as the costs are shared. The diagram shows the gravitational field lines of a planet. Outline how the diagram shows that the gravitational field strength of planet X decreases with distance. The field lines are farther apart at greater distance from the surface. So concentration of lines here is greater, here is smaller. The diagram shows part of the surface of the planet X. The gravitational potential at surface of planet X is -3. Gravitational potential at Y is -V. So we should show sketch on the grid the equipotential surface corresponding to gravitational potential of -2. So the formula is inversely proportional to radius. For Y we have 1, 2, 3, 4, 5, 6 units. -2 should have 3 times less units, so 2 times less units, so it will be 3 units. And we draw a sphere, right. A meteorite very far from the planet begins to fall to the surface for negligible small initial speed. The mass of planet and its radius is. The planet has no atmosphere. Calculate the speed at which the meteorite will hit the surface. So meteorite is coming from very far, and when it comes to the surface, it gets negative potential energy and positive kinetic energy. So change of potential energy equals minus change of potential energy. So formula for potential energy is this. So change of kinetic energy, half mv squared, equals change of potential energy from 0 to this value. Then we rearrange for V and we get 2 significant figures because, for example, here we have 2 significant figures and here we have 2 significant figures. At the instant of equal, the meteorite, which is made of ice, has temperature 0. Assumes that all kinetic energy gets transferred into thermal. Calculate the percentage of meteorite's mass that melts, the specific latent heat of fusion. So kinetic energy turns into heat, and energy required equals L times percentage multiplied by mass. So all kinetic energy has melted some percentage of mass, right. So we arrange and we get 52%, 2 significant figures. Here, attention, when you use the speed, use speed with 3 significant figures, not with 2. So 2 you give in the answer, but for next step you should use 3 significant figures. A student is investigating a method of measure the mass of a wooden block by timing the period of oscillation on a spring. Describe the condition required for the object to perform simple harmonic motion. The restoring force is proportional to the displacement and in the opposite direction, or acceleration is proportional and opposite in direction to x. So here we have some information. So we have mass and period. Then we change this mass by wooden block. And we have new period. So we should find the mass of this block. So mass 1 T1, mass 2 T2, formula for period from booklet. T squared will be more useful. So T squared, ratio of squares of period equals ratio of masses. Rearranging for mass 2, we get the formula with answer with two significant figures. In carrying out the experiment, the student displays the block horizontally by 4.8 cm for equilibrium. Determine the total energy in the oscillation of the wooden block. So block was displaced. This is the formula for kinetic total energy from booklet. Omega equals 2 pi over T. So we have all information required. Displacement we turn into meters, so everything will be in SI system, and this is the answer with two significant figures. A second identical spring is placed in parallel to the experiment in B is repeated. Suggest how the changes affect the fractional uncertainty in the mass of the block. Spring constant would increase because we have two springs in parallel. A period will be smaller. As a result, fractional uncertainty in T will be greater, and fractional uncertainty of mass, which is calculated using T, will be greater. So, with the block stationary, longitudinal way is made to travel through original spring from left to right. The diagram shows the variation with distance of displacement of coil is spring at an instance of time. A point on the graph has been labeled that represents a point P on the string. State the direction of motion of P on the string. So, I decided to show that after some time the wave has moved, and as a result of this movement the P appeared to the left, so it was moving to the left to appear to the left. So as the wave moves to the left, next moment P will display to the left, so movements to the left. Explain whether P is at the center of compression or rarefaction. So let us look. So this is negative, so all particles have moved to the left. Here all particles have moved to the right, leaving P as rarefaction. Question 8. State Faraday's law of induction. The psi of induced EMF is proportional to rate of change of flux linkage. Flux linkage is NF. So here we have transformer. So we have primary EMF 240, number of turns primary so much, secondary so much. Explain using Faraday's law how transformers step down the voltage. So here a lot of points, so we should describe the action of transformer and explain why the voltage is decreased. So varying voltage in primary coil produces a varying magnetic field. This produces change in flux linkage. In the secondary coil, a varying EMF is induced. In the secondary coil, voltage is stepped down as there are more turns on the primary than the secondary. Very tricky. So input voltages, so calculate output. So we use formula from booklet 11.2, rearrange for ES and get 12 volt. Outline how energy losses are reduced in the core of practical transformer. So we laminate core to reduce eddy currents, and we make such a shape that less thermal energy is transferred to the surrounding. Step-up transformers are used in power stations to increase voltage at which electricity is transmitted. Explain why this is done. So we don't want high voltage, but we should decrease current. To decrease current, we should increase voltage. So for certain power to be transmitted, large V means low I, and less thermal energy losses for heating, because formula for power in the cables will be Ri squared, so we decrease I to have less losses in the cable. Question 9. Two observations about photoelectric effect are: for light below the threshold frequency, no electrons are emitted from the metal surface. For light above the threshold, the emission of it is almost instantaneous. Explain how each observation provides support for particle theory, but not the wave theory. Observation 1. So particle, photon, particle which is photon, energy is given by this, and if energy of photon is less than work function, no effect is observed. In wave theory, the energy of electromagnetic wave is independent of frequency, and with very high intensity we should get this effect, but this doesn't happen. Second observation, instantaneous. So particle and single electron absorb energy of particle theory. Single electron absorb energy of single photon in an almost instantaneous interaction. In wave, it will take time for energy to build up to eject the electron. The graph shows how the maximum kinetic energy of electrons emitted from surface of barium metal varies with frequency. So they give us only this part. This part I should make red. I'll make it red. Right. Determine the value of Planck constant. So according to this formula for kinetic energy, gradient of this graph is equal to Planck constant. From graph we find point 1 x1 y1, point 2 x2 y2 as far as possible from each other, and the formula for gradient we find h, very good value. State what is meant by work function of a metal. So minimum energy required to remove electron from the metal surface. So actually it is electrons near the surface that are escaping. Calculate the work function of barium in electron volt. So from the same formula, work function equals y-intercept. From graph we find this y-intercept, and then knowing that one electron is so much, we divide this value of joules by 1.9 and get in electrons. So let's see. Intercept. So intercept goes, and we have -4. The experiment is repeated with metal surface of cadmium, which has a greater work function. Draw a second line on the graph to represent the result of experiment. Straight line with the same gradient but greater y-intercept. So let's see how it looks. This one, so it is cadmium. Intercept is greater, and the same gradient. Paper is over. Thank you for your attention.